Hello guys, welcome back to our channel ChandraAwesome. In this today's video, we will complete about other tools that are working with the sheet metal. As in the previous videos, I keep on uploading about the sheet metal tools, how to work with them along with the tutorials. I hope you might understand them and knowing about the tools. So let's work with the other tools. And the previous we had completed up till sheet metal model and flanges. And what is hem? Hem is it is also like a flange, but it it going to bend the metal into a complete this flange is like it's also same, but it is going to bend the metal like as shown. Let's for example, let me show you. So let me change the angle. This is how the hems looks like, and here also you can do the same operations, but it do not have any partial hems like that. So the whole metal face is going to be bent into complete 90 degrees. So you can't have any degrees until you have that roll. See, this is the straight hem and this is the roll. Why this is not rolling means that about inner radius. Let's say 4 mm, or 3 mm. See, okay. Based on the inner radius, it is going to be rolled. This is about rolling the sheet. By using flanges, we can't roll the metal, but with the hem, you can do that. And we have another called teardrop. It should be like 15. So it is going to be straight with a complete bend like this, the other shape button, and you can also increase the distance like a total length. Okay, and this is the alignment in place or outer. So I already explained you about this hem in the practice model of sheet metal, and this is the corner type, this close or simple. You can see the difference when you're working with the tap viewer. Okay, so that is about how it works with the hem. Let's close this, and we need to work with other tools called tap. So what is the use of this tap feature? These tap feature are basically used to add the sketch faces to the sheet metal as parallel to it. So let's show you an example. I draw a sketch on this face and I'm going to select this face. So when I select this face, it is going to be measured with the sheet metal face which I drawn from it. So we are saying flanges to merge. So it is going to merge it, and if you want to move this sketch to other faces of sheet metal that is parallel to it, you can also do that. Like for example, it is parallel to this one, right? So when you click on the face, so the same tab face is going to be added here also. See, it is possible you can do as many parallel sketches as well. If you can do here, you can do the same for the other side of tools. Don't mind about the noise, guys. Sorry for that. I'm trying my best to get the good voice. So that is how to work with. And the subtraction scope is used to remove the already added parts. Like it is like how to work with the surfaces, like mutual trim surface. I'll explain you how to work with this. So this like we are adding, and this is like we are subtracting. So this is going over constraint because we're already working with the sketch. Okay, that's the difference. So like this, we are going to work with the tab feature tool, and we have another called make joint. The make joint tool is going to create a joint between the two unconnected faces of sheet metal. Let's for example, you can see this face and this face are not connected of the sheet metal. So you can connect them by using the make join. It is asking edges or sides. So let's select faces of it. So see, so they are going to be added at the exact extreme point where they meet each other. So this is the end of the point the two metals should meet, and we have two types. One is rib and one other is bend. So ribs have another drop down for edge joint. This is like edge joint, and we have butt joint with one direction, and we have another direction of butt joint. So you can see the changes when I click on butt joint directions. It's going to change overline about it. And we have bend. So when we click on bend, the two metals will join and create a bend together. So here you can also use this same metal model bend radius, or else you can do the manually. That's for example, you can match here. Like for example, should be 20. It is two inside, right? Or equal. So by giving the bend radius, you can create. You can also make joint like this. This is how it is possible to work with. And when you work with a flat view of the sheet metal, you can observe it. So the curve is finally formed here. Okay, that is the work with the make joint tool. And another one is corners. Corners is guys. So when the three sheet metals are joined, there is corner is formed. I already explained you in the previous video also. So you can customize the corners by manually head here also. Let's for example, here the corner is idle there, so it is not possible to make a corner here. Let's for example, let's work with this. It is defaultly selected as simple, but we don't want the corners like this. So how to change the corners? Just select any edge point of it, and the whole corner is going to be affected. And we have customized corner types. For example, here I have rectangle scale. It should be changed like this. Let me show you the flat view also, then you can understand. Let me zoom it. So these are the corners you're working with. This is how to be going to be changed, and you can also round the size. Small is too small, successfully applied. It's too small. The rounds is like let's increase the radius. See, this is how the round size corner will form, exactly like circle. And we have round scale. Scale is much, it will maintain some offset distance. Okay, and we have close. This is how the close works. And we have simple. This is the simple one, and the closure should be like the closed corner. It should be like it do not have any bends. Let me show you how to work with this. Let me edit it. Will actually get default by it, but you can also add. So let me remove this place. The actually future will look like. So let me edit it. Let me sell the another model. Here you can't see the flat views. So simple corner is nothing but like a close. It is default selected, that is not going to be changed here. but the closed corner should be like as shown in the edit model, like this. This is the closed model of the sheet, corner of the sheet. Okay, so we have another tool called bend relief. So the bend relief is mainly used when we're working with the flanges. So when you're going to bend the sheet metal, we maintain some bend relief. So that time the other sheet metal will not get into effect. Let me show you. For example, let's apply a flange to it, at least for the side. It is not going to be possible. Let me sell this face. Maybe due to the distance, it is not able to possible to add the flange. Okay, let me work with here. Let's edit the sheet model and remove this band. Now click OK. Now let's work with here with the flanges. We can't, because it is closed side, right? That's we can't able to create there. This is also be closed. That's why it's not working for here. So let me edit this, make join, and you can see the face here. Let's apply flange here. Now it is going to be work. See, why does it not work? Because it is a closed joint. You can't do any operations here. That's how it's working. This is the flange, right? And when you apply the partial flange, there is some bend is automatically added here. It is actually forming the bend as tier. As for example, you can see it is actually following the tier bend. So like it will only affect like this, and it when you perform the this bend of without blend, this don't have any bend relief. That is the use of it. Okay, let me OK this. Now work with the bend relief tool and select the edge. So the bend relief is going to be added to here. So when I click on this, we are going to select any points that is connected to it. So I'm going to select this point, and you can see the bend relief added. So when you work with the bend relief, it will not affect the other sheet metal. That is the use of bend relief, and you can perform any one. As you can give two. Sorry. You can give how much distance you want, and let's default is a 5. And we have types of bend reliefs also, that is this over 5. We have square, we have rectangle scale, and we have oversize, or bond scaled, up round, sorry, and tier. This is the tier we are actually working with. So when you work with the others one, we had extend bend relief, see, which means it is possible to bend when you perform other operations. That is the use of it. Okay, so that is the use of bend reliefs. So when you're working with the manufacturers, then you might understand how to work with the sheet metals, and what is the actual things of bend relief, and these are the technical terms we must know about in working with the materials. Okay, so that's all about sheet metal tools, guys. I have completed all the tools, and we have another one is final sheet metal model. So what is the use of it? So when you're working with the sheet model, the other tools will not to work except with the sheet metal tools. So we can't draft, we can't make a hole, we can't patterns, we can't boolean. So most of the tools will not work. So if you want to any changes on this model, we need to make this sheet metal model into complete one. So when you work with the complete sheet model, the sheet model will completely convert into a solid body again. So this is the sheet model I selected. So when I clicking on it, so it is becomes like a solid body now. Now you can perform any fillet operations right here. See, now the fillet operation is going to work here because this is a solid body now, not a sheet metal. That's what is the use of final sheet metal model part 2. So you can perform the graft operations, you can perform extrude, see, you can perform extrude, you can perform thin, you can perform boolean, everything you can perform the move switch tool also. It's actually possible. So that is the use of this final sheet metal tool. I hope you might understand what I trying to teach you about sheet metal model tools. So this is how to work with them. Now I think you can able to design sheet metal models in Onshape CAD software with my teachings. And if you really get the required information from our videos, please do like, share, and subscribe our channel, guys. I really need your support to mm, increase my sharing about my knowledge to others CAD designers who are willing to learn. I almost completed the software, and we need to only work with the future scripts and updated tools and other is of surface tools and curves. I will complete within 2 videos about it. So I can also make one of them into shorts so you can understand them easily. Okay, from then onwards we will discuss what we are going to learn. Okay, that's all about today's topic, guys, and thanks for watching. Have a nice day.